Kinetics is a powerful method for investigating and predicting reaction behavior under different conditions, where measurements are difficult to perform, or where the reaction times are very short or very long. In just 4 simple steps, this video will show you how to predict reaction behavior from DSC measurements in METTLER-TOLEDO's STAR-E software. METTLER-TOLEDO offers 3 distinct options for kinetic analysis in their STAR-E software package. These are Nth-order kinetics, Model Free Kinetics, and Advanced Model Free Kinetics. The Nth-order kinetics package is based on a very simple model, and as a result is limited to simple reactions. Model Free Kinetics, as the name suggests, does not require a pre-selection of any kinetic model, and is applicable to simple and complex reactions alike. The kinetic calculations are based on 3 or more dynamically measured conversion curves. Advanced Model Free Kinetics is the most sophisticated method of the 3, and extends the possibilities of MFK in that it can use any dynamic or isothermal temperature program, or a combination of the 2. This video describes the procedure of Model Free Kinetics, or MFK for short. MFK calculates the conversion-dependent apparent activation energy to make reliable predictions about reaction behavior. In MFK, the model-free approach of Weisshoffken uses the so-called isoconversion principle. This states that, at any particular conversion, the reaction rate depends only on the temperature and is independent of the heating rate. A webinar dedicated to MFK and other kinetic methods is freely available on the Internet. In the remainder of this video, I will describe the MFK evaluation method, which can be summarized in 4 simple steps. 1. Perform at least 3 DSC or TGA measurements at different heating rates. 2. Calculate conversion curves from the measured curves. 3. Calculate the conversion-dependent activation energy from the conversion curves. 4. Use the calculated activation energy to predict reaction behavior under different conditions. Step 1. The data used in this example originates from DSC measurements, although the same procedure can also be used for TGA. Open at least 3 DSC curves, measured at different heating rates, in the evaluation window. Determine the reaction enthalpies for each measurement by peak curve integration. It is important to select the correct evaluation limits and baseline type. The reaction enthalpies, or mass loss in the case of TGA, should be more or less equal. These limits are later used to calculate the conversion curves. Step 2. While holding down the Control key, left-click to select all the DSC curves. Select the DSC tab and click on Conversion. Add the preferred DSC conversion settings in the pop-up window. Click OK. The generated conversion curves and tables will appear in the evaluation. The tables can be deleted from the window. The conversion curves should be inspected carefully to make sure they do not cross over each other. Paying special attention to the small and high percentage conversion areas. If any crossing over is detected, then adjust the DSC integration limits and/or the baseline type accordingly. Step 3. Next, we would like to obtain the activation energy curve as a function of conversion. To do this, select all the conversion curves and, under the Kinetics tab, click on MFK in the Model Free Kinetics group. The activation energy curve is displayed in a new coordinate system. Step 4. In the last step, select the calculated activation energy curve. In the same ribbon bar, select Conversion Parameter Settings from the Settings group. Specify the desired conversion parameter settings in the pop-up window's entry fields. For example, maximum time, 60 minutes. Temperatures, 60, 80, and 100 degrees Celsius. conversion: 10%, 60%, and 90%. When finished, click OK. Next, return to the Model Free Kinetics group and select Applied, followed by Conversion Plot and Table from the drop-down menu. The predicted conversion plot and table is displayed in a new coordinate system. Following the same procedure, you can also obtain predicted ISO conversion curves by selecting ISO Conversion Parameter Settings and entering the desired times. In thermal analysis, we generally use dynamic measurements to obtain the experimental data and isothermal measurements to check their predictions. The diagram shows two conversion curves for an isothermal DSC measurement. The green curve is that predicted using the Model Free Kinetics program, and the blue curve is the isothermal DSC measurement at 60 degrees Celsius. The excellent agreement between the experimental data and the prediction is proof of the effectiveness of Model Free Kinetics for this investigation. You have seen how easy it is to predict reaction kinetics using METTLER TOLEDO STAR-E software. The diagram is a summary of the 4 steps. 1. We define the reaction peaks and draw baselines for the integration. 2. We calculate the conversion curves. 3. The conversion-dependent activation energy is calculated from the conversion curves using MFK. And 4. We use the data to make predictions. For more information on the topic of kinetics, we recommend you to refer to our UserCom articles and webinars, which are highly appreciated and shared among the scientific community.